Hello, everybody. This is Bridging the Client-Side, Server-Side Divide. Hopefully, you're in the right room. You probably are. Even if you're not, don't leave. We've got kind of difficult sight lines in this room a little bit. Hello, people behind the column. This is what I look like. Hi. I won't really be doing anything interesting besides useful gesticulating. So if you can see the slides, you're good. If you can't see the slides because you don't have a good angle on the projector, this is kind of a chicken and egg problem because I put it on the projector, but the URL in the bottom right has a link to my slides. It's seanmcb.com/client-server-divide. And if you're not allergic to hashtags on Twitter, I made some up for this session. If you use FluentConf as well as Divided, I'll look at all those tweets later and try to respond. And my Twitter handle is smcbride. If you want to reply me to ask questions during the talk, would be more than welcome. So I should start off by introducing myself. My name is Sean McBride. I am currently an engineer and web developer at Typekit. And for those of you who don't know what Typekit is, it's a hosted web font service. So basically, if you make websites and you want to put fonts on them, we work with the foundries who actually make fonts in order to license those for the web. We have a whole library that's available as a subscription. And we also have a whole technology platform for ironing over some of the cross-browser consistencies that exist in web font implementations today. And previously to Typekit, I was at Google as a user experience web developer, so building prototypes and also doing design to convince sometimes skeptical audiences. And I probably don't need to explain what Google does to anyone? Okay, good. But I am kind of curious about what all of you do and who you are. I've never spoken at an O'Reilly conference before. This is also my first time giving this talk. And I've also never spoken at Fluent because Fluent hasn't existed until now. So how many people in the room are developers or engineers primarily as your job? Okay, overwhelming show of hands. Of those people, how many of you guys write primarily JavaScript? That's the most of what you write. Okay, a lot of people, but maybe like half. How about something else, like Ruby or server-side stuff is primarily what you do? Okay, and a little bit of JavaScript on the side, a smattering of those people. Do we have any non-engineers? Like, do we have any designers out there? A few people, awesome. I love that. And how about product people? Like, product-y? All right, also like 2 hands. Anybody I didn't get, like astronauts, gardeners? All right, we don't have any unique flowers today. No, so that's expected for a JavaScript conference. We've got a lot of JavaScript people, and we'll be talking a lot about JavaScript today, but also some other server-side languages and how those fit together. So I should start off by introducing where I got the idea to give this talk in the first place and really what I mean by a client-server divide. And this all started at Typekit when we were implementing a new font browsing UI. So this is our old font browsing UI. It works pretty well. It's where people come on the site to find the fonts that they might want to use on their website. And so they need a way to look at our entire library and sort of quickly drill down to filtering by a certain type or a certain visual style and getting to a smaller set of things that they might be interested in using right away. And we wanted it to be fast and easy, and this interface was not really necessarily so fast. Every click that you did to filter something would basically load a new web page, refresh the whole page. This was a very much traditional sort of server-side application. And we had found in thinking about redesigning this that a lot of the metaphors that we had worked, but we really wanted an experience that was much more app-like in the interactions, where you would click and it would just immediately respond and change without a full page refresh. And we wanted to do that because we wanted the experience of browsing for fonts to be 3 things. First, we wanted it to be fast. We wanted to get people to the fonts that they were interested in using and be able to explore quickly so that there didn't feel like there was this penalty for trying new things and for experimenting with different styles. We also wanted it to be fun, so using animations and other sort of visual feedback to suggest to you how fonts are related, how things are narrowing down, and basically make less of a penalty for trying stuff out. Like, oh, I wonder what happens if I combine these 2 attributes. We don't want you to have to wait for a whole page refresh to find out what the result of that is. And then finally, we also needed it to be accessible. So we're a little bit different in this application than some other JavaScript's client applications in that these are pages that are available to logged out users. They're part of the main flow of our site. That's the listing of all of the fonts that we have, and so those get indexed by search engines. We want to be the first place, the first result on the web when people search for, like Proxima Nova or Museo Sans. And so we need these not just to be accessible to humans with browsers that support JavaScript, but older clients that don't have JavaScript and potentially bots that are just crawling the web that may not even evaluate JavaScript at all. So unlike a client application that's just a tool where we can say, well, JavaScript's required, we sort of had to be able to serve some sort of content that was still useful even without JavaScript. And so if you drew what we had sort of on the server side and on the client side in our application beforehand, we basically have a Ruby on Rails application on our server and just kind of a tiny smattering of jQuery throughout the front end, providing little bits of interactivity and behavior. And we quickly realized that that model wasn't really going to work for this kind of experience that we wanted to build. So we had to figure out what else can we put there? What other tools could we use? And this was also a good opportunity to take advantage of some of the new client-side tools and libraries that were coming out. So taking a step back, we sort of realized that this is part of a larger pattern that you see in web development. There's basically two patterns that you see commonly. The first one is basically what we have, which is like a large server-side application in Java or Python or Ruby or what have you, and then a little bit of JavaScript on the client just to add some behavior on top of that. But you can think of the bulk of the application as being living on the server. That's where the meat is. And then in contrast to that, more recently we've been seeing a pattern that is shifted to the other side, where the bulk of the application is on the client, written in JavaScript or maybe CoffeeScript or another language that compiles to JavaScript, and using a bunch of the new front-end frameworks that we've seen coming out in the last few years. And then, of course, that's talking to something on a server that's treated more like an API. It's probably still written in those languages, or maybe it's not even something that you maintain. Maybe it's an API that someone else created. But at any rate, the bulk of the application is seen as being on the client. And what we realized is that we already had this server-side application that was significant, but we really wanted to start doing more significant client-side stuff as well and have those play together, so kind of operate in more of this middle ground where we had a significant portion of our application on the server as well as a significant portion on the client. And our goals that we thought why that would be a good idea is that, first of all, this would allow us to serve JavaScript and non-JavaScript clients. If the server application can actually serve pages that function by themselves and stand alone, then that supports our older clients or bots that don't have JavaScript. And then we can also layer on top this rich client-side application for clients that do. And in a more general sense, we thought that it would provide us greater flexibility in our user experience. So some interactions on our site work very well in sort of this app-like context where you're clicking things and stuff is instantly changing. But other parts of our site work pretty well as just a sequence of web pages where you click a link and the page refreshes. And we sort of wanted to have the flexibility of using whichever interaction model felt natural for any given part. Some of the downsides, though, as we explored these ideas of how to achieve this was that you tend to run into a lot of code duplication because you're not using the same languages on the client as you are on the server. There's JavaScript in one place, something else on the server. If both are media applications, you're going to end up needing some of the same functionality in both places, and you might end up having to write that twice, which is annoying and difficult to maintain. And another difficulty was moving data back and forth. So just keeping things organized between a significant client application and a significant server-side application, having those two communicate with each other, organizationally just gets complicated. So there have been some recent developments in the JavaScript space that have made this easier, and one of them for sure is Node.js. So this idea that, oh, hey, why don't we just run JavaScript on the server? Now we're writing the same language in both places, and we can actually just share code back and forth between the server and the client. And your application doesn't really care if the next asynchronous callback is executed on the client machine or on your server somewhere in the cloud. It's not a big deal. That eases a lot of the code duplication issues and also some of the communication back and forth. But unfortunately, we did not live in a world where we had Node.js on the server, and we're not really going to be able to do that. We had a significant server-side application already. It was in Ruby on Rails. We weren't going to ditch the whole thing and start over. And we actually like our server-side infrastructure. We didn't really want to change it. We just wanted to find something that played harmoniously with it. And so we ended up striking on something that actually worked, and I think there are sort of three key qualities of that, or aspects of it, that made it work, and I'm going to talk about those today. The first one is this MVVM pattern, or the idea of model, view, view model on the client. That is probably the worst name for a pattern ever, but I will explain what it means later. Declarative bindings is the second thing in order to create a really dynamic UI, and we'll talk about that. And finally, client-server rendering, or the idea of being able to render the same set of templates on both the server and the client. And we'll talk about that as well. And the result was something that really achieved all those goals for us and is possible to develop. It's organized and maintainable. And if I switch over here, we can see that here is the site in a browser with JavaScript enabled. And so I can click these links, and I just instantly get narrowed down to the sans serif fonts. Or if I go back, and then I want to see the serif fonts instead, and then I want to see serif fonts that come in wide widths, and then those will load in. And so this experience just allows us to quickly explore fonts, and it feels very much like an application. The cool thing is, if I switch to a different browser, this is Safari, and I've turned JavaScript off. And if I click these links, like say for sans serif fonts, you'll see that we get a full page refresh. We don't get the fancy transitions. And we're also not bootstrapping font loading because we don't have JavaScript. But all of the content is still here. We know what these fonts are. These links go to the font pages. A crawler could come in and index this and follow all these links, and things would just work. So we were able to sort of get the best of both worlds, and we'll see how that was done. So diving into the first topic, getting better organization of this client and server code with MVVM model. So there have been a lot of JavaScript libraries in the past few years who have enabled you to write code sort of in this new style. Not even all of these existed when we started this project, and so we didn't actually evaluate all of these. So I haven't tried them all, but this is just a collection of the ones that I know about, and I think there are even more, because I saw a slide like this yesterday in a different talk, and it had others that I'd never heard of. So this is definitely an exploding space right now. And a lot of these libraries use different names for the type of structure that they enable you to write applications in. You'll see MVC a lot, which we're familiar with from the server side, MVP, MVVM, and all three of these, so model view controller, model view presenter, model view view model. You can see that the difference are basically the glue. We all know they all have a model because we need to put our data somewhere and have a model for how that data works. They all have a view because we're going to have templates and some way to present that data to our users. And basically, these all differ based on how do we think about what ties those two things together? What's the glue that's in between? So model view view model is a pattern that comes from sort of GUI application development for the desktop. And it's the idea that you have data models which have sort of information about the data in your application from a data perspective, like what are the core objects that are in a database or something like that. And then a view model is another set of models, but they're much more concerned with what types of objects you have in your interface. So you might have certain types of objects in your database, but those might not directly map to the stuff that's in your UI. And view models take the data from your actual database models and sort of transform them into a different interface that matches the interface that you're going to present to your users, the user interface. So there's sort of a translation layer, and then the views attached to those view models and have all the specifics of how is the information displayed and sort of the styling and stuff like that. I think people could probably argue for hours about like the subtle and minute differences between these different patterns and whether or not that is really the pattern that you say it is and are you applying it correctly. I think all of these are useful patterns to think about, and as we'll see later, we sort of abstracted and bastardized MVVM a little bit anyway, so I don't really care so much what name is used. I just chose to use MVVM because that is the name that the library that we ended up choosing chose to use. We evaluated some of those libraries and ended up deciding on Knockout. It had some features that we really liked, and it was also pretty small in terms of its footprint, which we liked because we wanted to start with something relatively lightweight. Most of this talk isn't really very specific to Knockout. Some of the code examples come from Knockout, but you could achieve a lot of the stuff that I'm going to talk about with many of those other frameworks that I showed earlier. So if we go back to this client-side, server-side divide again, we already had an MVC model on our server side. Ruby on Rails uses MVC. We've got models and views and controllers over there. And what we wanted to do is start using this MVVM model on our client side. And we had to figure out how to sort of make these two play together. And the first step was realizing that actually the models for model view, view model are really the same models that we have on the server side. So we actually just want to use the same data models in both contexts. We want to think about that data as coming from the same place. So we don't really need a separate set of data models on the client side. And that's a thing where I think MVVM in desktop GUI apps, you always get into these hair-splitting arguments about, does this belong in the model or does it belong in the view model? And when the model is code that's on your server and the view model is code that's on your client, the distinction of where things should belong actually becomes very clear. So that was sort of the first step. To go into more detail about how that looks, we had our models on the server side. Those are like active record models for Ruby on Rails. We've got controllers which accept requests and sort of route that to an action and then figure out how to pull together different data that the page is going to need that we're going to render. And then over on the client side, once we serve JavaScript, we've got these view models, which are objects that understand what are the concepts in my user interface and how do those concepts interact with each other. And we need to get some data to those view models in order to be instantiated. So the first thing that we did is create this idea of a view model adapter on the server side, which is something that doesn't have any of the behavior guts of a view model, but just basically is a shim that knows which data properties the view model needs and can sort of turn that into JSON and get it over to the client. And then once we have view models initiated over there, we have our templates over on the client side that we can render. And in our case, those are just HTML and bindings, which we'll look at later. And then the last thing that we realized is, well, we've got the templates, and in order to render them, we really just need the data, and we sort of have an idea of what the data that's going to be necessary on the client is from this adapter. So maybe we could go ahead and render the templates on the server as well, and just not have any of the interactivity or behavior that's on the client. And so we were able to do that. So we'll look at how that worked. The first interesting thing I think to look at is ferrying data from the server to the client. So how do these view model adapters actually work to help us get data from one place to the other? So starting out on the server side, if we look at some Ruby code briefly, this is like a really simple data model, database model of a user, and it has a billing name property. And then we have this thing which is a view model adapter. So we've got a view model on our client that represents a person in our interface. And we can basically make a person with this class method from a database model of a user. And what this does is it maps the server-side data properties to the associated client-side data properties. So our client-side person view model has a name, and we're going to get that name from the user's billing name in this case. The cool thing is that you can actually map different data models to the same view model. So we might display our users from the database as people in our interface, but we might also display people that come from Twitter as people in our interface, and we might also display vendors in our backend as people in the same user interface, and we might display admins, which are stored in a different database model, as the same view model on our interface. So you can kind of marshal the data from lots of different types of database models into this one view model that's going to be presenting that data in the interface. So if we look at the code to sort of get that together, we get a particular user record, and then we pass that into this view model adapter, and we get an instance of that. And if we convert that to JSON, it basically just serializes itself into here are the properties and the values that are going to be necessary in order to initialize a view model of that type with that person's data on the client. And from there, we can send that over to the client. So then looking at client-side code, this is a really simple example of a view model on the client. It's our person. They just have a name, and that name is a property that's observable. We'll find out what that means a little bit later for declarative bindings. And then we just decided on this convention that all of our client-side view models have these standard update methods that take a JSON data object and just expect certain properties to be there and assign those to the right properties on this view model object in order to initialize it with all that data. So we had the data on the server, we got it into the right format that it expected from any number of database models, and then we ferried that over to the client where we're able to sort of initialize this client view model, which deals with the concepts that are in our interface instead of the concepts that are in our database. So the first thing I think about MVVM is that it helped us to organize client and server code. We have sort of now a very structured opinion on which types of code go in which places, and we have a framework for just knowing where to put things. We don't have to make decisions each time about how are we going to build this and how are we going to build this. There's a pattern to follow. Another thing that it helped us to do is to be able to move data back and forth between the two worlds. And then the last thing that it helped us to do is to reduce some duplication by not having to write things from scratch every time. We still have a little bit of duplication in that we have this server-side representation of a view model's data, as well as a client-side full implementation of that view model with all the data behavior as well. So in the places where we couldn't eliminate duplication, at least we've organized it. We have this strict relationship between here's a client-side view model with JavaScript code, and here's some associated Ruby code on our server with the same name. The file name structure is very logical and defined so that we know where to look to find that associated code. We don't have to sort of hope that we can figure out where we put it next time. Next thing that I want to talk about is building dynamic UIs with declarative bindings. So declarative bindings are a separate concept, and if we go back to looking at this this slide full of JavaScript libraries again, not all of these provide the concept of declarative bindings, but some do. Based on looking on the internet, I think these are the ones that do. That might not be exactly right, but I'm pretty sure. And so declarative bindings are a really cool feature because they make a lot of the guts and nastiness of writing interfaces a lot easier. So if we go back and look at this client-side view model code that we have again, we've got a person, and that's a concept that's going to be in our user interface, and they have a name. And that name is this observable, which this is from Knockout, so ko.observable. And that is basically just a property that has a number of aspects about it, but one is that it can be bound in a template. So then if we look at a template, for example, we've got this person, and we've got their full name, and the data for that full name is bound to text is name property. So it's saying that the text of this element should be whatever the name property is. And we could render this right now because it's just HTML, and we'd get full name blank because there's nothing in this element. But if we instantiate a view model with my name, so it's a person with the name Sean McBride, and then we apply that view model to that element so that those bindings are applied to that element, that view model, rather, what happens is that that element fills up with the text of my name. So it connects that property with the text of that element. And the really cool thing about these bindings and these observable properties is that because they're called observables, it's because when they change, there's notifications about that change, and that propagates throughout the whole application. So all I have to do is have a reference to my view model and say that my name is changing to Oscar the Grouch instead of Sean McBride. And if I just set that, immediately every template where that's used just automatically updates. And there's no render methods to call. I don't have to remember to call update on different code. It's like magic. It just works. All of the subscriptions to make that happen are set up behind the scenes when the initial templating happens. The other cool thing about these bindings is that they're bidirectional. So I've got now an input tag for full name where the value is bound to the name. And then below that, I just have a normal element, which is the text is bound to the name. So if I render that with my Sean McBride person view model, we can see that my name is in that element, and it's also the value of the input field. But if I start typing in the input field, that value is propagated back to the view model, and then from there back to all of the other places in every other template where that value might be used. So I can delete my name, and it deletes the other representation of the name down there, and then as I type something new, that's propagated in real time out to the rest of the model. So that's actually one of the most confusing things about using this style of programming for interface design is people on the web aren't used to stuff updating right away. Like as soon as you change the model, that propagates everywhere. And so you actually have to kind of be careful about when you change the model. And there are some ways to sort of make changes atomically or throttle changes so that they don't trigger too often. So that's a brief look at declarative bindings. There's a lot more that's cool about them. But I think some of the cool things are that they mean that templates are just HTML. We don't need any sort of angle brackets or mustache brackets or other sorts of brackets that are something made up in order to do templating. It's actually just a set of attributes on the DOM that we understand what they mean and take them as instructions. The other thing that's cool about them is that we don't have any more messy render methods. So we don't have one method somewhere in our code that's like a bunch of jQuery that's targeting different class names and setting text. And I think that that approach kind of gets brittle over time because you're tying the specific implementation of the template into the actual JavaScript code. Whereas in this case, all our JavaScript code has to care about is sort of the concepts in our interface and how they interact with each other and what their behavior is. And all of the specific stuff about what class name that should result in or what color it should turn something stays in our templates and our CSS, where we can change it easily without having to change the code. And then finally, I think declarative bindings are cool because it means we don't have to think about updating. As we saw, we just change something on the model and it updates everywhere. We don't have to remember like a tree of subviews that we need to sort of propagate that change to and make sure they all know that something has updated. And then the last thing I want to talk about is reducing duplication with client-server rendering. And so this is the idea of rendering templates both in the client, but also being able to render that same set of templates on the server as well. So if we go back to this picture that we saw earlier, you remember we had our server-side model and controller, and then we had this view model adapter that was responsible for transforming data from our server models into something that was appropriate for the client-side view models that we have. And the thing that we realized is that with that data and the templates, which are just these declarative bindings, we could potentially take that data and apply it to the declarative bindings on the server side instead of on the client side. And since we don't need any of the behavior, that's a lot smaller of a set of stuff that we really have to worry about. And so I'll show you a little bit of what that looked like. So if we go back to our server side view model adapter again, this is the thing on the server that keeps track of what data is necessary for the client side view model. We can instantiate one of those from a database record. And instead of calling to JSON and serializing it into something that we're going to send to the client, we can actually create a helper on the server side which points to a template and actually takes that adapter for the data source and renders that template on the server. And so this is our Ruby helper that we made, and you give it a template name of the client-side template that you want to render on the server, and you give it an instance of a view model adapter which has the necessary data that would be expected in that view model. And we can do all of the same rendering on the server. So how that works exactly was sort of interesting and exciting to figure out and was not entirely straightforward. Interesting thing about declarative bindings is that they modify the DOM. So just like the browser has a document object model of the whole page and knows how the elements are related, it's not just a random string of content. That's the way that bindings work. They modify the text of something or one of its attributes. And so we actually need a DOM on the server. So we need a DOM implementation. So for that, we ended up using Nokogiri, which is a Ruby library that's a DOM implementation on the server. So now we have a DOM just like a browser would, and we understand this template in terms of elements. The next thing that we have to do is figure out what the bindings mean. And in Knockout's case, at least, bindings can have JavaScript expressions inside of them. So they're not just a simple like property colon value kind of mapping. You can have text colon first name plus last name, and that plus is actually a JavaScript expression that gets evaluated and concatenates these two strings together. So you can't just, in my simple example, of course we could, but for real bindings in Knockout, you couldn't just evaluate them without actually evaluating JavaScript. So to do that, we actually have to have a JavaScript runtime on the server. So we decided to use Johnson, which is a Ruby wrapper around SpiderMonkey, which is a C implementation of a JavaScript runtime. And we use that in order to get the values of the bindings that we need to apply. So the general flow looks something like this. We get the template source, the actual string of template code. And then we go through and we find all of those binding attributes, and we get all of the binding strings out of them. And we take that and combine it with the view model data that we have for all of those data properties. So now we have the bindings and we have properties, and we evaluate those. We send them off to JavaScript runtime, and we evaluate them and get back the values. So that turns text colon name into text should be Sean McBride. So now we actually know what our binding values should be after we've evaluated them in JavaScript. And then the next thing that we have to do is turn the template from just a string of characters into an actual representation of the DOM using Nokogiri. And then we go through that DOM and we execute each of those bindings with the values that we got from evaluating them in JavaScript. And we modify the DOM. So we add the text here of this element. And then once we're done with that, and we have the modified DOM, we turn that back into a string. And now we have the rendered template string that we're going to send as part of our resulting web page. So drilling into the two interesting parts of that, I think we've got using Johnson server-side to evaluate bindings. And so basically, this is pretty simplified, but you just call Johnson and you say evaluate some JavaScript, and you give it a string of JavaScript. It goes into the JavaScript runtime, evaluates that code, and then the resulting return value is sort of transformed from a JavaScript object back into a Ruby object. So in this case, we have code that just writes out a variable name for each of the data properties in our view model adapter, and then we just have our binding string there, text:\name. We interpret that as an object literal, and then we return the resulting value back, and that gives us that text should be Sean McBride. That's super simple, but obviously they get more complicated. And then the second interesting part is using Nokogiri on the server side to apply those bindings. And so if we go look at what bindings look like on the client side again, we have these elements, and they have these attributes saying that text should be name. And what the implementation of a binding actually looks like is something like this. So for the text binding, for all the bindings, there's an init and an update. Init is called immediately as soon as that binding is applied the first time, and it sets up the initial state using a reference to that element and the value that you're going to do. So in this case, we would set the text of that element to the value. And then update is called every time that value changes. And it's basically, okay, now we need to update the text of that element with some new text. And the thing that we realize is that for the server, we don't actually need to implement update. Update is only used for a dynamic UI where the values are initialized and then they change. And we only need to render the initial state on the website, on the server side. So we only actually needed to implement half of each of these bindings. So what that looks like on the server side is something like this. We just have our set of bindings. We register a text binding handler, and it gets an element and a value. And we just set the element's content to the value as a string. And that's 1/2 of the text binding. And that's all we had to do for text. So we actually implemented the full set of knockout bindings as a server-side binding handlers so that we could render all of the same bindings on the server as well. That's a brief overview of that. So client-server rendering, I think, is interesting for a few reasons. It gets us to our goal of serving both JavaScript and no JavaScript clients. We've got a full content coming from the server that is just fine. All of the links actually point to other pages that the server actually knows how to render. And so that actually works. We've got full data coming from the server. But then when it gets to the client, if it does support JavaScript, it basically instantiates this whole client-side app and replaces all that content with stuff that's dynamic. And we've done that without having to have a horrible amount of duplication, which is nice. So yeah, another aspect is that it reduces duplication. We've written only one set of templates, and we can use it in both places. That was really important. We didn't want to have to have an embedded Ruby set of templates and a knockout set of templates that both implement the same interface, and then keeping those in sync would just be a disaster. One downside of client-server rendering is that it can definitely slow things down. We found that even though we tried to optimize as much as possible, we experimented with different JavaScript runtimes and found the fastest one that we could. And we also, the fastest one with bindings for Ruby anyway. And then we also made sure to make as few round trips as possible. So we actually batch up all of the client-side templates on a page. We get all of the bindings, and then we send all of those over to JavaScript to be evaluated in one giant batch instead of making a bunch of small round trips. That sped things up, but it can still be a little bit slow. And but the good thing, the upside of that, is that client-server rendering can actually be disabled for clients that have JavaScript. So of course, after doing all this work, we can actually turn this off for clients that we know have JavaScript turned on. And so we do this on the Typekit site. When the first page loads, we send the full everything rendered on the server. And then if we detect that you have JavaScript enabled, we actually set a cookie that lets the server know, hey, stop rendering server-side templates for this person. They can get an empty page because they're just going to have everything rendered in JavaScript as soon as the page hits. And if you turn JavaScript off for any reason, you'll see a page that looks like this. We left a little thing in there to say, oh, you've turned off JavaScript. All right, well, we'll get rid of that cookie, and you can go back to having pages rendered on the server as well. So quickly wrapping it up so we have some time for questions, putting it all together. We've got this diagram that you remember from before, our model, our controller, the adapters, which can send data, package up data, and send it to the client for those view models, as well as use it to render on the template. If we sort of look at what that looks like, just the overall picture in pseudocode again, we're getting an instance of a data model, using one of our view model adapters to turn it into an adapter instance, which on the server we can use immediately to just render a client-side template on the server. But we can also package that up, serialize it as JSON, and send it over to the client, and we can initialize a view model on the client with that same data. And that view model has the full set of interactive behavior and the code that actually makes the client-side application run. And then that same view model can be used to render the same template by applying those bindings on the client as well. So that was how we were able to basically take an MVC architecture on the server and sort of meld this MVVM client-side architecture together with it in a way that actually made sense. And the first step was realizing that the data models that we wanted to use were actually just on the server. We didn't need to duplicate those. And then really, since we've been able to share the views, I guess you could view the views as coming from the server side as well. So now all that we're really left with is these view models that define the client-side behavior and how client-side concepts interact. And that's the unique code that we really just wanted to write in the first place. So that's the only thing that we have left to write. So it's great. And with that, we were able to achieve our goals of making something that was fast, and that was fun, and that was also still accessible to clients that don't support JavaScript. So that's bridging the client-side, server-side divide. Thanks. I wanted to mention really fast, just like everyone else is mentioning, that Typekit is hiring. So if you're interested in doing cool JavaScript stuff like this and making the web a more beautiful place, I would love to hear from you. Just send me an email. And then I also wanted to show how to vote for sessions, because I tried to do this earlier and I fucked it up like 5 times first. So you go to the app and you find the session, and then you scroll down and there's this rating. You have to click the number of stars that you want to vote for, and you're not done yet. That hasn't been sent to the server. Then you have to click this gray button, which looks like it's disabled, but it's not, and that submits the rating. So I would love it if you would rate my session, because I would love to be back. So yeah, with that, I'll go to, there's my email address down at the bottom if you'd like to email me. That URL has a link to the slides if you want to go back and take a look at anything. There's all the hashtags and my Twitter name at the top again if you want to tweet questions. I'd love to answer longer questions by email, and I'll take some questions in person right now. So go ahead. Yeah.
Actually, I have 2 questions. The first is probably really fast. So is your view model base an open source gem that we can use? Or is it something so specific to what you do that
It is not an open source thing right now. I think this whole pattern could be wrapped up into like an open source gem that could be used with Rails. And it's sort of like about halfway there right now, probably. Unfortunately, like, I was really excited to open source it, and then like we got acquired by Adobe. And so now I'm figuring out how open sourcing works in Adobe. And they do have an open sourcing program that actually works, but I just need to like learn how to use it. So that might be a while. If anyone else wants to go out and write this based on my presentation and open source it, I'd be ecstatic, and I'd just start using that instead. But yeah, I do think this would be really well extracted into like a gem that works with Rails. Yep. Yeah. Yep. So, yeah, so the question was about validation is another area where you run into lots of duplication. You have to have validation code on the client side because you want to give a good experience with quickly saying, oh, that value is not accurate. But you also have to implement validation on the server side because someone can just hack your API and send in invalid values, and you need to protect against that. We haven't done a lot of user input stuff in this model yet, and so we have not yet gotten to that problem in order to solve it. I think that you could basically go 2 roads. You could start going down the road of doing the validation code only in JavaScript and executing validation code in JavaScript on the server, but now you're kind of going into this weird hybrid, like your half-node model, like you're executing some JavaScript on the server and some Ruby. Another thing that it's kind of totally unrelated to this, but we have a set of font filters that filter a family of fonts down to a particular set, and we use those both in the JavaScript code, and we also use them in our application in order to like only add a certain subset of the fonts to your kit. And what we did with those is we created a place in Ruby where we have these Ruby classes that each represent different font selection strategies. And we have the same strategy implemented. Since it's only a tiny bit of code, we have them implemented in Ruby and JavaScript right next to each other. The JavaScript just in like a heredoc string, basically. And then we have tests that actually just like one test that runs a loop and verifies that for all of our test cases, all of the results are the same in both implementations. So we use Johnson in the test suite in order to evaluate and make sure that our JavaScript code does the same thing as our Ruby code. So that's another approach, is like if you can't avoid duplication, at least put the duplicated code right next to each other and say, here's two implementations of the same thing. And you know that when you change one, you're going to change the other because it's like right there. So, yeah. Yeah, we did not. We actually kind of, because we came to the problem incrementally, kind of like bit by bit, we didn't come at it from like the whole hog side, which would be like, let's just run knockout on the server. And so we didn't actually try that, and we could have. I worry that the JavaScript speed thing would become even more of an issue when you have to like basically load this whole library into memory. And the other thing we found out is that either the bindings or the C library itself for JavaScript execution is leaky because we can't keep a runtime context around for too long. So we can't like load the libraries in once and then just keep evaluating stuff inside that context for too many times, or we started getting memory leaks on the server. So it's possible that that would work. The actual implementation of the bindings is really small. Like we have one file that's basically all the helpers to make this happen, and it's about like 400 to 500 lines of code. So like it wasn't a ton of code, and I think that's the only reason why it sort of felt okay. The other reason why it felt okay is that it felt like something that is generally useful. It's something that anyone who wanted to use Knockout and Ruby together in this way could use. And so our goal was eventually to open source it, and I think it still is. Yeah. Okay, last question, go ahead. Yeah, so I think the question was about is the real benefit to supporting JavaScript and non-JavaScript just the client-server rendering, or is the other stuff about how to structure your code sort of also necessary to get that benefit? I think the primary thing in order to achieve that goal is definitely client-server rendering. But the problem with client-server rendering is that in order to render a template that works on the client, you have to have an exact matching set of data on the server. And so knowing what data properties that you need to have there on the server in order to, and what they should be called in order to render that the same way on the server, without doing the other stuff about organizing your code so that you have this one-to-one relationship between the thing that's used to render it on the client and the thing that's used to render it on the server, you end up having duplication anyway that's not related in any way. It's like, well, we know we need this set of attributes for this template. We know we need this set of attributes for this template over here. And there's no way to tell that those two sets of attributes are related in any way. So instead of making the templates the central thing, the knockout model is sort of to have the view models be the central thing, and you can sort of render whatever template you want as long as it has the right properties. So we sort of took that same approach of making the view model a central thing, having it in both places. And that was another aspect that allowed us to do the client-server rendering, but keep things more organized and have less duplication. So I don't think it's strictly necessary. You can get client-server rendering with Mustache or other styles of libraries. And we also investigating using Mustache, but there were other reasons why we decided not to do that. Mustache, you basically, if you want to update a part of the DOM, you have to re-render the whole template, whereas when you're using knockout bindings, it just updates the content of that one DOM. So that was the reason why we stayed away from Mustache. Sorry, did that answer your question? Oh, okay. Come ask me afterwards or send me an email. I would like to answer it. All right, and apparently that was the last question, so I'm sorry. But head to the break in the next session, thanks, and send me email with more questions if you guys have them.